handles that you can buy with or for tools are metal, and I personally don't like the metal handles, because to me they feel cold, and I really just don't like it. It's just a personal preference. So for the most part, I make my own tool handles whenever I can. I've got some of the metal ones that I use for tools that I don't use very often, basically because somebody gave me the handles, but I just really don't like the cold aluminum or whatever they're made out of, so I prefer the wooden ones. Handles are really fairly easy to make. They don't take a lot of time. You can make them as fancy as you want. I personally don't like a lot of doodads and stuff all over the handles, because it just detracts, I guess, from it. I'm more functional than arty, I guess you could say, when it comes to that. So the handles that I use are pretty much straightforward. As far as designs go, as far as handles go, all the commercially available tool handles that you buy with handles that from Craft Supplies or Packard or any of them, most of them come with wooden handles on them. You can just cheat and steal their design. This one's a Henry Taylor, I think, or I don't even remember. That's a design that I stole from them. This is one I stole from Sorby when I made this one. So there's a number of different styles that you can use. This one here, the handle, I made the handles because of these quick release mechanisms up top here. When you're doing demos, especially when you have to fly somewhere or go for a long distance, the handles that are on the metal tools, or the tools, get a little weighty, and they cost you money, because when you fly they charge you by the pound. With these type of quick release handles that they have for this, you can bring a whole series of tools and they just fit in the handle and lock into place, and you've got one handle that you can use for 15 different tools depending on the diameter. I've got these from 5/8 down to 3/8, and they work really well for what they are. The quick release mechanisms are a little expensive, but to me they're well worth the money, simply because of the convenience that allows you to take a bunch of different handles with you. So there's another option.
Roughly how much are those handles?
I think they're about $40 a piece, I think. I don't remember now, but they're for something like that, they're well worth the money. There's another type of handle that I made, patterned after an old gouge that I used to have that I kind of like the handles on. I don't like it as much on this one, and I probably wouldn't do this again, but there's another option for tool handles. In addition to making handles for turning tools, Craft Supplies sells pizza cutters, potato peelers, ice cream scoops, a bunch of different stuff that require handles for, and the technique for making the handles for them are basically the same as making tool handles. So it's something that you can use for a lot of different applications other than for tool handles for the shop. So you can pretty much use any type of wood that you want for handles. I really prefer ash, simply because I like turning it, but cherry, walnut, maple, anything will work. I had a piece of maple in the shop that was already cut to about the right length, so I just brought that along today. So like I said, you can use any type that you want. Sometimes the handle blanks have little waney edges on them, and it makes it kind of difficult to find out where the corners are, because normally when you locate the centers, you just connect the corners. This one was a little bit more difficult because I really didn't know where the corner was at. So basically what I did is I just took my pencil, put it like this between my fingers, and just drew a square all the way around the outside edge here, and then I just connected the corners on that square that I had the inside there, and it seemed to work out okay. What I like to do when I start out with this is somehow put a little pinprick right in the center there, because dot to shoot at. If you don't put that in there, you're just kind of going blind, and it's hard to figure out exactly where the center is. But it really doesn't matter if it's off a little bit anyway, because this is big enough to do what we want. So I just use an awl and locate where the center is, and just put a little mark there. The other thing that you can use, this is a spring-loaded center punch that really works great. It's just a matter of finding the center like this and pushing down, and it makes a nice little mark in the center there as well. So that's a handy tool to have for some of that as well. So, getting ready to mount the stuff on the blank on the lathe. I like a cup center for the tailstock end. The cup center has a cup around there that'll produce a ring, and it's also got a small point in the center. I like this one a lot better than a regular 60-degree cutter, that live center that some people use. I found that 60-degree center acts like a wedge sometimes, and you can actually split small pieces of wood if you put a little bit too much pressure on it. This, you don't have that much of a problem doing it because it distributes the force out a little bit on a wider area. The other thing is I turn some natural edge bowls at times, and the 60-degree center just puts too big a hole in it, and you can't make minor adjustments if you want to, where this you can. So that's what I use in the tailstock end. This I've had for probably close to 30 years or better. I got it from Craft Supplies. It does a really nice job. It comes with different centers here that you can put in there, and I've been thinking about buying a new one because this one's getting pretty much beat up, but it still functions. So that goes in the tailstock. The headstock end, normally you have a 4-prong center that a lot of people use in this. People have been starting to use now what they call a safety center, that basically is just a dead center that they used to use in the tailstock end. The advantage to that is it kind of prevents catches, because instead of actually keeping spinning, if you get a catch, it actually stops it, and you don't get as big a catch when you're doing it. I like this particular, where are we at? I like this particular one. It's called a stab center. It's got a point here that is spring-loaded, and then it's got all these little teeth that are around the outside edge. I don't know where you're going to focus.
Right there.
Yeah, these teeth around the outside edge that really hold it fairly securely. It comes in different sizes. I've got one that I think it has a 1/2 inch diameter, and this is about 7/8. But I've been using these more and more lately because I like the way it holds better. With the 4-prong center, you almost have to drive the center into the wood, and again, you've got a problem with the chance of splitting it, and I just don't like it as well. A lot of people will put the 4-prong center in the lathe there and just crank the dickens out of the tailstock to drive that in there, but from what I understand, it's not real good for the bearings in the lathe. So these are rather expensive. If you get the actual stab center, they're about 70 bucks a piece, but I noticed that Penn State Industries has them for about 30 bucks or a little bit more. They evidently must be a knockoff of some type. So that goes in the headstock end. So mounting this is pretty much straightforward. You just line up the little pinprick that you made in the end there on the cup center. I find it easier to put the tailstock in first and then advance this one. That's just my own personal preference. Lock that down and then tighten this up until the teeth bite in, and it doesn't take very much to get it going. You can lock the quill down on the tailstock if you want to. A lot of times I don't, unless it's something that I'm really worried about coming free. Setting up your tailstock, your tool rest, basically all the different tools have different thicknesses, I guess you could say. You can see the difference between these two a lot. If you're going to use this tool, the tool rest is going to have to be a lot lower than if you use this one, because basically what you're looking for is having the point of the tool on center, and you can check that just by kind of lining it up on the end of the tailstock and guess. There's a lot of leeway in there, so it doesn't have to be absolutely perfect, but it should be somewhere close. Now for this tool, I'm a little bit too high. If I were going to do that, so I would drop that down a little bit so I'm more on center, but that's the difference there. This one, I'm going to drop it down a little bit more, and that's about right. Now, keeping your tool rest parallel to your piece of wood helps you a lot, because you can get a straight cylinder that way. Because basically what your tool is going to do is follow that, because what you're doing is actually rubbing your finger along the edge of the tool rest and holding your wood like this. So basically wherever the tool rest is, your finger is going to go parallel to that. So if you've got this cocked at a little bit of an angle, you're going to get a taper on it. So since we want a straight cylinder out of this, I'm going to get this so it looks parallel to my stock, and it eliminates a lot of problems that way. Now, when you're doing this, the easiest way to do this is have the tool rest, the handle of your tool up on your hip, and then holding it like this. So basically what you've got is you've got it anchored here, you've got it anchored here, and you've got it on your hip. And basically what you're going to do is just move you from your ankles like this, keeping everything stationary. If you try to move your arms like this, you don't have a lot of control over it, and you're not going to get a straight cylinder. But by just rocking like this, it makes things a lot easier. So any questions up to this point getting things mounted on the lathe and getting going?
What speed are you using?
It doesn't really matter. We don't have a readout on this, so I really don't know. I'm just going to turn it up to where I think it should be and let it go.
This is as close a chart as we have.
Oh, yeah.
And then whatever the number is.
Yeah, it's just, I just turn it up till it looks good, and then I go from there. Normally the smaller the diameter that you're working with, the faster you want to go. I would say this is going somewhere, I'll end up about 1200, somewhere in that neighborhood. I guess it's a personal preference. Jimmy Clues says, Jimmy Clues is a professional turner from the UK that's now living in Las Vegas, and I've taken a couple of classes from him out at his shop, which is, by the way, would be a good class if anybody wants to sign up for the AAW scholarships. Jimmy has classes all the time in his garage with anywhere from 1 to 5 students, and Vegas is right just a stone's throw from his house. The strip is, so you can combine a turning vacation with a fun vacation afterwards if you want. But Jimmy's a really good instructor, and you'll have a lot of fun if you do that. But anyway, back to what he says. He says you should turn it up till you're scared and then turn it down a little bit. And that's pretty much what he does on some of the stuff that he turns. But he turns a lot of stuff that's not completely round, and so you've got speed is a little bit more important on that than anything else. Anyway, so we'll get this going. I've made sure everything's not touching. We're all ready to go. I normally turn with a face shield on, but I forgot it this morning, and by the time I remembered it, I was too far away to go back home and get it. So we'll just have to do the best we can here, stay out of the way. So basically what I'm going to do is anchor things. I'm going to get things going, start on the end here, just move back a little bit each time, just to knock the corners off. Now they've got something that's called the ABC rule, which basically stands for anchor, bevel, cut. So basically what you're doing is you're anchoring your tool, getting it all set up. You're getting your bevel set up so it's cutting rather than scraping, and then you're actually making your cut. I like to add a third one to that with a D, ABCD, for direction. You always want to go from your largest diameter to your smallest diameter whenever you're doing spindle turning or bowl turning for that matter. It just seems to cut better, the fibers go. As far as the bevel goes, like I said, you're going to get a lot better cut if your bevel is rubbing rather than scraping. So basically what the easiest way to do is just bring your tool up so it's touching, and then lift your handle up so it starts to throw shavings right there. Now you know the bevel is rubbing, and you're going to be able to make your cut without having a lot of scraping cuts. I'm going to turn this up a little bit higher and finish getting this rounded off. And you can go in both directions. And you'll see the chips start to form a little bit different shape, more curls, once you get close to round. Now you can check it just by putting your tool like this, and you can still see it's bouncing, so that tells me I've got a little bit more to go. The other thing you can do is actually reach around and feel it like this. Never feel from the front because you could suck your fingers down between the tool rest and the wood, and it wouldn't be nice. You can see the difference in shape now of the shavings. So that tells me I'm probably pretty close to round. And there's a little bit left, but we're getting close. Okay, that's good for now. A lot of people tell you not to move the tool rest while the lathe's running, and then they go ahead and do it anyway. Working with kids as much as I have, I've learned that they'll mimic anything you do. So if you tell them not to do it, then you go ahead and do it, they're going to do it too. So you're best to learn how to do it right. So we get the rest of this rounded down. And at this stage, it doesn't have to be perfect, because all you're doing is getting your blank rounded off now. And that looks like it's pretty much round all the way up through. All right, so now the next thing we need to do is attach a ferrule to this end. Basically what the ferrule does is just prevent that little thin section there from splitting if you get a catch or something, and it's a good safety feature. Most of the ferrules that you buy on your tools are generally brass. That's traditionally what they used to use. Brass pipe is difficult to find, so a lot of people are going to copper plumbing fittings, and they work just as well. They just don't look as traditional as the brass does. I was lucky one of the guys from the Erie Club had a bunch of brass pipe that he bought from, I don't know, he's always going to auctions and buying all kinds of junk. And he bought a bunch of brass pipe and cut it up into 7/8 to 1 inch sections and reamed out one end of it after he cut it, and just they have them in the tool cabinet up there that anybody who needs some can just grab whatever they need. And so it makes a nice source for that, because brass does look better. So I've got one of these ferrules that he brought that I'm going to use today. The one end he just cut off with the pipe cutter, and it left a little bit of a ring in there, a burr on the inside, but I kind of like it because it caps off the end of it. The other end he ran a reamer through so that it got rid of that, and it makes it easier to fit it on the piece of wood when you're done. You can put the ferrule on either end. I found that it's easier to put it on the tailstock end because you don't have to fight with the whatever type of drive center you have, and actually you can actually leave this right on here if you want to once you get close to it, so that you can fit it. Fitting the ferrule is about the only touchy part to making all these things, because you want to have it tight. So basically what we're going to do is measure back. For this one I need 7/8 of an inch. And I'm going to give myself just a hair less, because I can always add more, but I can't take it away. I can make it wider, but I can't make it, or I can make it longer, but I can't make it shorter. And what I'm going to do is I'm going to take an inside diameter reading with this, with the dividers, and get somewhere close. And then I'm going to transfer that dimension get it close here. One nice thing, if you mess it up, you just have it end up with a shorter handle. And no one but you knows there's a problem. All right.
Do we have his tools in the back there? Did he bring them?
There it is.
Yeah, got the tools there.
Basically, your parting tools come in two different styles. One is what they call a diamond parting tool that has kind of a diamond cross section. The other one is a purely flat one. Both of them work well. The only problem with the diamond one is that, thank you. The only problem with the diamond one is that if you're trying to get up to a shoulder, the diamond one has a tendency to throw it off, and you can't really get a nice square corner that you can with the perfectly flat one. Like I said, both of them work just as well. Just any tool has its limitations, and that's the only difference between these two. So what I'm going to do is get myself in the ballpark for this. And when you're using a parting tool, it usually doesn't matter if you get that much of a clean cut on it, but at times if you're doing boxes or something like that, the fuzzies that the parting tool sometimes will leave, like this, are a problem, and there's a way that you can get rid of that by, I'm going to move my tool rest back a little bit because this one has a little bit longer point on it, and you don't want it resting on the point, you want it resting on the flat part back here, so it's even still a little bit too far away. All right, so by just putting it in straight like this first, you eliminate those fuzzies, and then you can go back and actually use it like you're supposed to by just lifting up the handle, but you don't have those fuzzies to deal with anymore. So what we're going to do is basically get ourselves in the ballpark. Get rid of some of this to get it out of the way. And then once I get, just like at home, you don't know where the tools are at. What I'm going to do is I'm going to hold the calipers in my hand. I'm not going to pinch them or anything. I'm just holding them. I'm going to bring this up against here like this, put it over the cut, and just let it slip through. And hopefully the cut that I made, or that I ended up with, is going to be bigger than what I need so I can kind of sneak up on it. So now I'm just getting rid of the excess, and now we'll try it and see what it looks like. I want to just take and knock that corner off a little bit so it's kind of tapered. It makes the fitting a lot easier. I guess red means stop. Okay, I've got a long ways to go, so I'm gonna, close. This is the part that's really fussy about getting this done. It's easier to be fussy at this point and take your time and do it right rather than have to start over because you got a little bit carried away. So what I'm gonna do, just going to take a skew and use it as a scraper. It seems to work really good for doing this. And I'm just going to work on the front corner. And what I can do is look at that cut that I just made and then look over top and line it up with the bed of my lathe to see if I'm actually straight. Put the taper on it again and check it. It's just going to be a whole trial and error thing to get this so it's good. And we're getting closer. There's really no easy way to do this except take a little bit, check it, take a little bit, check it. At least I haven't found a way. Now the reason I'm not going all the way down to the bottom is that if I do make a mistake, sometimes by still being tight down at the bottom, you can correct your mistakes. If you go all the way down, you're kind of stuck. All right, that's getting awful close. So I'm just going to take a little bit more off of that end there, and then I'm going to bring it down to the other end and see how close I am to getting it fit. Now the parting tool can be used as a scraper too, as long as you've got a light touch, and make sure that that's straight. Now, the shoulder here, I want it slightly undercut, because I don't want a little hump sticking up that's going to screw up my fit. Take to that corner a little bit and see where I'm at. I'm not used to the switch being over here.
It's magnetic, you can move it.
Yeah, I know it, but it's better there.
Okay. And you also have the switches down there.
Right. All right. Getting close, but still no cigar, so I'm going to take a little bit more off. Like I said, it's just something that you got to just be fussy with. Getting in a hurry now just causes problems later. Works pretty good. Just a hair more off and then we'll attach that. Once you get this part done, the rest of it's pretty easy. And one thing that you got to remember is if you take a 1/16 of an inch off at this end, you're also taking a 1/16 of an inch off the other side. So you're ending up with actually 1/8 of an inch being taken. So those little hairs kind of add up. All right, so I'm pretty close to this now. I'm not too far away. So what I'm going to do is I usually take a mallet, dead blow mallet on the lathe bed, and just tap that the rest of the way down just to make sure that it's good and tight. And it's seated properly all the way down. So that worked out pretty good. Now, sometimes if the ferrule is a little bit loose, what you can do is take a center punch and a metal hammer and just give it lay it down on a bench or something and just tap it with a center punch. It'll put a dimple in it and it'll actually make a little prong that's sticking in there, and it'll help to tighten that up a little bit more. See, there, that's better. All right, so now that's on there pretty much permanently. So now we can go back and turn the rest of the handle. Now, like I said, there's a lot of different handle shapes out there. What you'll come to find, something that you like the feel of, or the looks of, better than anything else, and that'll be pretty much what you can use for whatever you want to do. I'm gonna copy this handle today. It seems to work out pretty good for me. I've made them similar before, and it works out good. I kind of like this shape. It feels good in my hand, so that's what we're going to go with.
Excuse me, what are they, about 16 inches left?
I would guess, depending on how big the tool is, that's 12, so it's about 15.
15, okay.
Yeah, roughly 15. Obviously, the bigger the tool, the bigger the handle. Like I said, it's just all personal preference, what you like. So, let's just say that that's where we're at right there. I'm going to mark the transition points. There's a shape change. There's going to be a shape change. There's the end right here, somewhere around that area. And we'll just say that's another shape change. By shape change, I mean you're going to have a different diameter. So there's a major diameter, there's a major diameter, there's a major diameter, and of course then I marked the ends. So now we need to get the dimensions there. And all I'm going to do is just get a direct reading right off of this. And keep in mind, they don't have to be perfect. I get them close to the ballpark, and then I just see how much I like it. Sometimes you gotta make these marks a little bit more, because once you turn it on, sometimes you can't see it as well. So I'm just gonna mark that with my pencil. Take my parting tool. And run it into there. Now with these flat parting tools, it'll make a cut exactly the width of your parting tool. If you, excuse me, if you get in there too deep, sometimes it can snag on you, and you'll get a catch that way. So if you've got a flat one, I go in about 1/8 of an inch or so, or not 1/8, about 3/8 of an inch, and then I widen it out a little bit, and then finish my cut. With the diamond parting tools, it makes a cut that's bigger than the actual tool itself, than the cutting edge, so you don't really have to worry about that as much. Now, a lot of this can be done with roughing gouge. This is a little bit smaller one, and what I'm going to do is I'm going to hold this so it's touching my arm here, and I've got my finger down here. I can get a lot of control over that. I'm going to move that tool rest in a little bit. I can get a lot of control of that just by holding it that way. So it's just a matter of getting rid of the excess wood. So all I'm doing here is I'm just getting rid of that excess wood. I could have taken it down initially down to that dimension, but all I was interested in getting it round at that point. So now I've got it up to where I want it. Now it's just a matter of tapering this end down. And that's good enough for now. So we'll take this one down. So all I'm going to do is just get in the ballpark right now. And I'm always going downhill. I never want to go uphill. Go uphill, you're asking for a catch. It may not happen today, but eventually it's going to happen. So, that's close enough for now. So now I'm gonna get this other end down here. And I think what I'm gonna do is get my excess off to start with, down at this end, since otherwise I'm gonna kind of be running blind. Because what that does is just gives me some more points that I can start going down to. What I like to do is work each one of these things individually rather than going across. For me, I just found it's easier. And I've also found that if you go all the way across like this, every time you hit one of those parting tool cuts, it makes a little dip. And now I can go back and clean things up. Now I can go back there since I got those all worked down and just go all the way across and clean those up. Okay. We can go back and put our marks back in. Okay, now we'll go back over here, and basically what we're looking for is just kind of like a taper down. Now I'm not too concerned about surface finish at this point, because I can always go back and clean that up once I get my shape where I want it, or at least close. Now what I'm looking for is a nice gentle curve in there. And then we'll get our corner ready. We don't need that yet. And all I'm doing here is just getting my end point about where I want it. So now I can take a spindle gouge and just kind of start getting the back. all I'm doing basically is turning a bead. Kind of long one though. Alright, now we can step back and kind of look at things and see if there's any lumps or bumps in there. And I've got one right there, so we're going to kind of feather that one in. By going a little bit slower, I get a better cut. Should have had the guy here that was here last month clean this up for me. I've always been going to practice with the skew, but I just never get around to doing it. I mentioned Stuart Batty a little bit ago. He runs some classes out in Las Vegas. I think he's a 5th generation turner. His dad was very, very well known. Alan Batty was very well known, advocate of the skew. Stuart says the skew's only good for opening paint cans. So I guess it all depends on your point of view. So I'm going to start getting this down a little bit more to where I like it. I still got kind of a hump there. I don't have a lot of room to play with, but I'll get close to what I want. Round this over a little bit more. Now what I found is that if you're duplicating spindles, if you take your spindle and put it up against here like this and kind of line it up, you can tell pretty much if you're close. So what I'm doing is I'm lining up this edge here with that edge there. And if you kind of squint with one eye, you can get a pretty good idea of where you're at. So I'm a little bit high right in through here, but the rest of it, I can go down a little bit more there, but the rest of it looks like I'm pretty close to what I want. I can go down a little bit more in here too. But like I said, it doesn't have to be perfect. It's just got to be close because it's a functional thing, not an arty thing. So I'm going to take a little bit more off in here. And I'm going to take this down a little bit more here. So I'm getting close to the ferrule. You don't have to worry too much about hitting the ferrule because you can turn brass and aluminum and copper with ordinary turning tools, so you don't have to worry about them damaging your tools at all. And that up a little bit more. And we'll go down and clean up this back end a little bit. And you can see the shape taking place. So that's not too bad. I've got to take that down a little bit more now, but I'm going to do that later when I'm done. All right, now, sanding this is really easy. I try to power sand everything that I can power sand. A lot of the spindles and stuff that I do. The only thing I don't power, we got an extension cord?
On this side, Joe.
Right here.
Oh,
Right side.
all right, there's two basic types of sanding discs that you can buy. Maybe, there we are. You've got these padded ones like this. and you've got the flat ones like this. These are more rigid. I found these are good for doing outside curves, like down and through here I'll do that, and up in here I'll do that. The other ones I found that this one works better because it's more padded. They come in different grits. Normally you can go all the way down to 60, I believe. I guess it's commonly referred to as a 60 grit gouge. With this type, they've got these little ears on the back of them that six-sided prongs that fit into the mating holes on the other side. I'm sure everybody's seen those. Fit in the mating holes on the other side. So what you do basically is push them down till they snap, and then you give them a slight turn, and it locks them into place. So you don't have to worry about them coming off, but you got to get them locked into place. I'm not going to do a real good job of sanding this because I don't want a lot of dust in the air, but I'm just going to go through the motions, probably just do the 120 rather than the rest of it. So start things up, slow things down when you're sanding. And basically what I do is I just hold the drill like this. These right angle drills are really nice for that because you're not sticking out this way. You can cup it a little bit better. I hold it in one hand like this, the paddle on the other side, and basically what I'm going to do is just move my body. Any little imperfection that you might see, you can kind of feather it out. And it does a pretty decent job of sanding. The other one is Velcro basically, and with the Velcro you've got to be careful that you don't get it too hot, especially on the edges, because it'll melt the Velcro and then you'll have a hard time keeping it stuck. These ones come, I was going to bring some of the other ones and I forgot them. These are basically discs that have kind of a flannel back on them, and it sticks to the Velcro. These are just solid round discs. They've got some other ones that have little ears that come all the way around them that actually work better up into corners for inside of bowls and things like that, and I like those a lot better, but they both have their place. It's just a matter of getting these centered on the Velcro. They have a tendency to curl. Get it centered on the Velcro and tap down. And it's just a matter of sanding with those as well. I like to sand these barrels a little bit. Just to make them shiny. And that's basically all there is to making these handles and getting them in the right shape. So next thing we've got to do is get ready to part these off.
You gonna burn rings or anything?
I'm sorry?
You gonna burn rings or anything?
Yeah, eventually. So what I'm going to do is get these ready to go. You can decorate these things any way you want. You can put beads and grooves and burn marks and
It's by the mic.
yeah, whatever you want to do. I've got these are some of the arsenal that you can use. This is a homemade beading tool that a friend of mine made that when I had the magazine, he did an article on making these, Basically what this is just a piece of metal that he left a little bit bigger, and I'll pass this around, and you can see what he did basically is just take a drill bit and drill a hole down through there and then cut it off in the center. And it does a really nice job of making a bead. You can see the type of beads that it makes on the handle, so you know what size it is. So it's basically just a matter of coming in here like this and wiggling it. Until you get the shape that you want. Then basically what I would do is just take and knock off those sharp edges right next to it. Make the bead stand out proud. Then what you can do is I've got a piece of wire here that I put handles on. Basically, all I did is drilled a hole through the dowel rod. You never want to hold these things in your hands, because if it grabs on it, it's just going to snap your finger right off. Basically, it's just a matter of turning these on, putting the wire in the groove, and holding it there till it burns. And it makes nice little black marks to set things off a little bit. That might be hot, I don't know. That's just something I whipped up in about 2 seconds before I left. The other thing, you can make your own beading tools out of gouges. This is a round U-shaped gouge that I got from Doug, and all I did basically was just turn it over and put it on the CBN wheel, put it on there like this, got it lined up to where I want it, and I just basically pressed down a little bit until I got the flat in there, and it does a really good job. You use it upside down like we did the other one. It'll just make a bigger bead. And again, it's just a matter of wiggling it until you get the shape down that you want. And then again, like I said, I just knocked the corners off. So the thing stands proud a little bit like that. I guess you could make some, let's say I'll pass this around. That might be a little hot too. I've got those in a couple different shapes or different sizes that I started out with the gouges from Doug. In the center here, let's just say that we want to put some texturing in there. This is just a wheel. I don't even know where the guy got it from. There's a lot of different ones that you can have. This one I'm kind of partial to. Just a matter of moving this back a little bit, turning down my speed, and just coming across here. And making some texturing marks. I started up a little bit too far. Hopefully I can blend it in. And the one nice thing about texturing is if you don't like it, you can just turn it off and do something else. So there's a number of different things that you can do with this as far as decorating your handles. I'm not a fan of a lot of doodads on it, but, you know, that's your choice. There's just some options for you that you can do. Any questions up to this point?
How do you drill the hole?
That's where we're going next. I was going to show you how to drill it, but with this short bed, I'm not sure whether I can actually do it, so I'll just kind of run you through it.
You can make that longer.
Okay, we'll see what we can do. Oh, that might work.
Yeah, pull this, move that up just, there we go. Put that back then. Thank you, sir. It's been so
Yeah,
long since I used
we might be able to do that.
Okay. This tailstock is extremely heavy, so
Yeah.
I designed this and Pete Wade made it. And I normally put a wrench on there and snug it, but
So what we're going to do is get rid of this corner, the back corner back here. And what I want to do is continue that shape. And you can leave a little point on there if you want to. Again, whatever you like as far as shape goes. There's no wrong answer. How far you go depends on how confident you are. And it started to wobble a little bit, so I guess I'm not confident. All right, what you don't want to do is break that, because a lot of times what happens is the fibers will break down below and you'll pull a bunch of them out and it's a real bear to get rid of them. What I usually do is use a saw, bandsaw or something. What I brought along with me now is just a little coping saw, and I'm just going to cut this off. Then what I do is I use a utility knife and kind of tear that up. This doesn't seem to want to cut right, so we'll quit that. And then it's just a matter of taking your drill and blending everything in. So that you get a halfway decent tip on it. Like I said, you can leave any type of a bead or anything that you want on the end of that, just to make it look however you want. I'll pass it around real quick, like while we get ready for the next part.
Joe, I have a question. Can you put a big handle like that on any tool, or do you have to put some consideration into proportion and?
I would say proportion. Obviously, we wouldn't want a handle like this for the tool like this, or vice versa. So it basically it goes by the size of your tool. And what it's used for, spindle gouges basically have traditionally had short handles because it's more of a finesse thing. With bowl gouges, it's more of a power thing, so normally they have longer and stouter handles. So it's basically proportional to what the size of the tool is. So, anyone else have a question? All these drills, or all these tools have basically either quarter, 3/8, half, or 5/8 diameter shanks to them. So you don't have a lot of different sizes that you have to deal with. You can drill the hole out to start with if you want, by putting on the drill press, tipping the handle, or just setting it on the table depending on what the size of it is, and get a straight hole down through the end of it. And then what you can do, depending on what diameter it is, you can just put your cup center in that hole, and it'll make your axis that you want. If it's a larger diameter, like 5/8 for example, you can actually turn a plug with an end on it that you can stick down inside there and put your center on, and pre-drill your hole first. Either way works just as well. What I kind of tend to do is drill the hole afterwards. Normally I don't have a problem with it, but you know how demos go. If you're going to have a problem, it's going to be at a demo. Any questions on making these beating tools? They really work really slick, and you know, for the price of a gouge, you've got a decent beating tool. I think, is Doug making beating tools now?
I don't know.
Doug was talking about making beating tools, but sometimes he talks for a couple years before he actually does it. So I don't know if he does it or not. There's a company out in Washington called D-Way Tools. They make a really nice set of beating tools. And different sizes too, that work real well. Ashley Isles has some. I don't think they have quite the range that D-Way does, but they have some pretty decent tools.
How do you sharpen that small one that you showed us?
It's just about the same way.
It's over here on.
Oh, okay. Same way. It's just a matter of, you can take and run it on a stone, because it doesn't need a whole lot of sharpening. It just needs basically just honing. So what I do is I put this end in the back end here. That's why I like the taper on it. And it's just a matter of bringing this up. And you've got a point here that you used when you did your center. Now, if things cooperate, it's just a matter of holding on to it. And drilling the hole. And it doesn't take a whole lot of depth to do this.
What would you consider half, 3/4?
Oh,
an inch?
I would go in at least a couple.
Couple inches?
Yeah, a couple inches, maybe 2.5. They don't have to go down very far, but that's basically how you drill the hole. It's just pretty slick and pretty simple. Any questions on anything?
You just glue your,
Yeah, oh, good thing. As far as just like at home, I don't know where anything's at. Tool with the collet on it. Here it is, right in front of my face. Okay. All of Doug's tools have a kind of a tapered shaft on it, and that's basically all the farther down you need to go. Some of the other ones they don't have that little bit of taper down at the bottom there, so you just have to kind of let your conscience be your guide. What I do is I glue these in with epoxy. 5-minute epoxy works great. Before I do it, I take it over the grinder on the side of the wheel like this, and I make a few little V grooves in it just periodically. What that does is just gives the glue someplace to go, and it, rather than just on the side of the tool, it'll actually go into that little cavity there, and do what it's supposed to do. I smear glue all over this thing, and then I stick it down the hole. More than likely, you're gonna have to put a clamp on it, not for any pressure, but the drill bit has a tendency to move out, and so all the clamp does is just gonna keep it in there so it can't move out of it like it's supposed to. It's just gonna keep it where it is till it dries. I keep it there overnight, even though it's supposed to be 5-minute epoxy. I figure the longer you wait, the better off you are, and I've never had any come loose. To clean up epoxy, you can use white vinegar, and it takes it off pretty good as long as it's dry, or not dry rather, still wet. Obviously you don't want to saturate it with it, but just a rag will take off the excess so you don't smear up your ferrule and the rest of that business. So that's basically it. Any questions on anything? Okay, go make some handles.